So if I had this red graph, y equals f of x, and I've randomly picked a point and said that point is 8, 4. If I have a negative on the outside of that function, it will get reflected over the x-axis. And if I were to label a point on this blue one corresponding to 8, 4, I would have 8, negative 4. And we're going to expand our language a little bit. You know how outside the function was up and down and inside left and right? I'm now going to start describing up and down as something that's vertical, left and right as something that's horizontal. So now we have a negative outside of the function, and we call this a vertical reflection because it's moved vertically. Anytime you have something that's outside of the function, anytime that you have something that's vertical, the y-coordinate is the one that changes. Right? You move things up and down, what changes? Your y-coordinate. Now we have a negative outside, what changes? Your y-coordinate. And if I took this same graph and had the negative inside the function, we will start saying everything is horizontal. This is a horizontal reflection. And where would the point 8, 4 end up? If I flipped it over, it would be over here at negative 8, 4. So your x value changed and your y value stayed the same. So things inside the function affect your x values, and things outside of the function affect your y values. So right beside this, there's a little bit of space in the column. I'm going to get you to write down a couple of things. We're going to start with the outside of the function, and sometimes that negative is outside of the function on that side, and sometimes they could multiply by the negative, and the negative would be with the y on that side. And we say, if the negative is outside the function, could be with the y, then this is a vertical reflection. That's over the x-axis. And the y values get multiplied by negative 1. I'll scroll down, and then you also have time to write this one down. If the negative is inside the function, now it's with the x, then this is a horizontal reflection, which is over the y-axis. And the x values get multiplied by negative 1. Looks like everyone is done. Good. So let's go to example 1. Here's the graph of y equals g of x. Sketch the graph after a reflection in the y-axis. State the domain and range of each function. First thing I'm going to do is I'm going to underline this part after reflection in the y-axis. And I'm going to show you all the different ways of asking the same thing. Okay? If it's reflected in the y-axis, and you can sort of imagine it here, can you see that things are moving horizontally? So another way that I could ask this question is ask you to do a horizontal reflection. Horizontal affects the x. So algebraically, well, this is g, so I'll just algebraically, the negative would be inside the function with the x. And sometimes they don't say the y-axis. They might say reflection in the line x equals 0. Because x equals 0 is another name for the y-axis. It's good to be able to read something and then interpret it in different ways. To switch from reflection in the y-axis is a very easy graphical thing to imagine. Okay? But the g of negative x is also important for the algebra, because that's telling you your x values are changing. If I would take one point, if I would take this point here, negative 3, 1, and I flip it over the y-axis, right now it's 3 units away from the y-axis here, so I would have to go 3 units in the other direction, and you would have the point positive 3, 1. And you might notice that the x-coordinate got multiplied by negative 1. So now we can do this with the other points. This one's 1 away from the y-axis, so if I reflect it over, it would be 1 away. This one is 3 away, so if I reflect it over, and this one is 5 away. Connect the dots. And we have drawn the reflection over the y-axis. Read the question. State the domain and range of each function. So I will color code domain. Smallest x value on the red one was -3. Largest x value on the red one, +5. For the range, smallest y value, -2. Largest y value, +2. On the blue one, smallest x value now, -5. Biggest x value is 3. Smallest y value, still -2. Biggest y value, still +2. Does it make sense to you that the range didn't change? Because if it's a horizontal reflection, that negative is with the x. Only the x values are getting changed. Your y values would stay the same. But your x values did get multiplied by -1, so your domain did change. I'd like you to write 3 and 13 above this one, and circle those two numbers.